Hey, Coffee Compiler Club here today. In theory, to talk about compilers instead about can I make new Coffee Club shirts and send them to Europe, or will I get tariffed to death for sending a free T-shirt? Not claiming that there's any particular president, trying to stop everyone's fun, but could be the case. Um, and then let's see, Simon was going to. You have a bunch of stuff, Simon. Do you want
That's
to
true.
go?
Yeah, sure. If people are interested,
Can
you
go
can share, and then I
share.
can
I'm
talk
looking for
about
the correct
all the
share button.
things that came up over the last few weeks.
Yeah, I'm finding all my other buttons but the correct share button. Why am I missing the correct? Hang on. I'll share the document in a second here as soon as Slack figures out, oh, they hit it down here. The most obvious document to share is at the bottom of the stack. All right, there you go.
Yeah. So one of the rabbit holes I entered recently was looking at the history of x 86
Right.
and how the different extensions came to be. And one of the interesting things I found, which was not really documented before I did the work, was how Intel's own secret 64-bit extension for x86 actually allocated the bits. As we all know, AMD 64 had this Rex byte ahead of it,
Yep.
which gave them 4 bits that they could use. And compared to that, the earlier design from Intel that never saw the light of the day did things completely differently. And
Yes.
instead, they used
Yeah.
a specific bit pattern in the mod RM and the zip byte,
They
and
got
they said
six bits per register.
five, five.
Well, five. One, two,
Yeah.
three. Oh, four, five. You're correct. I'm sorry.
Yeah.
Okay.
So that
Okay.
they basically said, well, if the mod RM byte, well, if the first two bits are 0, 1 and the last three are 1, 0, 0, and the index of the zip byte is 1, 0, 0, then we have like this specially grafted hole um,
Yeah.
in the spec that were where we explicitly said like years ago that this combination is invalid, and if that combination occurs, the
Right.
design from Intel proposed using modRM and zip bytes and uh, bytes from the displacement to introduce two
Wait.
registers with potentially 5 bits to refer to
And the
registers.
displacement lost 3 bits?
I think two
No, two bits
and
for the
yeah,
second
three
bits
and MR. Yeah,
MR.
that's
Wild. Okay.
yeah. So and that's basically the only thing I could find that actually told the story of how it was supposed to work, and I'm not even sure that's what the chips actually did because that's just from the patent application Intel filed in 2000. And of course, they could have done completely different things, but
Yeah.
it was nice to investigate these
I
things. And
remember when Intel kind of folded and
yeah,
said, we're going to do the AMD bit pattern. And I was kind of shocked. Like, Intel's the king of not invented here.
yeah,
And we're like, we do it our way or go to the
yeah.
highway. And here they were like, oh, okay, AMD won. I'm like, fuck, Intel, what the hell happened? Fine.
External market forces probably. But
All
I mean
right.
the interesting thing is about x86, x86 this way around. That seemingly they built some encoding and have some extension points saying, yeah, well, we keep these bit patterns reserved for future extensions, and they never use it for future extensions. I mean, we
Right.
have like this for x86. I think the VEX encoding also had reserved uh, patterns. I think they had like 5 bits for um,
I mean,
referring to different maps of
Intel
encodings,
was the
and they only
first.
ever use two, and it's kind of wild. And now they have like what extended,
Yes.
enhanced vector extensions. Or so. Completely lost track, and it's always completely
I
stuff
mean, they ran
they
first
made
into the
up.
problem of needing holes in the opcodes to
Mm,
allow more extensions. And then they kind of went whole hog on the and more extensions and more holes and more extensions and more holes. Like Risk Five was careful to
mm,
like carefully set themselves up to have some good sized holes so that they could have all these extensions in. And then they've been filling them in gradually and they have a lot of holes remaining.
mm.
But Intel, like, the whole opcode's filled in except for these handful of holes. And then, oops, we need the holes. Okay. Well, let's make more holes in the next one and more holes and more next. It's a wild thing. Yeah,
Um,
let's roll on to your unions because I can now pull out my 20 odd ancient microprocessor chip architectures books that are not chips that died years ago. Some of them are pretty cool, but they're all dead
mm,
now.
yeah. Other topic, like a short update on what I did with Core recently. So I'm working on this union design. I've presented from time to time, and that's like basically the first code example of how it's supposed to look like in my language. And it was pointed out to me that the design I'm ended up with is basically united modes from Algol 68 revised edition,
Yeah,
and
yeah.
they have basically exactly the same approach.
Well, is the
And
union have a real tag?
yes,
Okay, so the actual implementation buries a tag under the hood when you make a
yeah,
pet, but
exactly,
a cat won't have a tag and a dog won't have a tag.
exactly,
Yeah, okay.
yes. And it turns out also the C# people are experimenting with this idea. Um,
Yeah, okay.
I haven't seen them yet figuring out that they're also just reinventing Algol 68, but maybe in time. So
Somebody should figure that one out, but I mean, it's not important to have it figured out, just important that here is this interesting design.
yeah, exactly. I mean, it's basically if you map the whole space of possible union designs, it's basically you can have them like tagged and untagged, and
Yeah, yeah.
can have them referring to existing types, or have them refer to types you just made up
Right. The
within
the
the
existing types for me is the interesting new direction. I've seen the plenty
from
of them that
Algol
said I'm
68.
making.
Sorry.
Yeah, go ahead. No,
No, I was just kidding.
well, I didn't even hear what you said because I was talking.
Sorry, yeah, you mentioned the new thing, and I was just mentioning, well, it's from 68.
Yeah. Yeah, I was seven then, so I missed it.
Oh, I just spilled my coffee. Uh, yeah, well, so that was kind of interesting that the old new, the old things are new again,
Yeah,
and
you had this write-up on Discord that I'm going to repeat here for Coffee Club people, which basically for space of your tag or you're not, or you're checked or you're not, or something like that. And the end
yeah,
result was, C has different bit patterns and no tags, and the user keeps the knowledge of which bit patterns are valid elsewhere.
yeah,
And of course, it lets you pun pointers to ints to pointers to ints and break every security on the planet, and that's C for you. But it's also terribly efficient because there's no tag overhead if you happen to know. And that everybody who
Mm.
writes, and I'll add this, everyone who writes like an interpreter of any kind immediately has a generic WAD value that the interpreter deals with that underneath the hood is tagged int, float, double, pointer, something. And then that taggy information is carried around somewhere, but not necessarily in the object. And so the pattern of having a union of different things is really common for certain implementation patterns. And then if you have a
And
tag and you check it, you're all type safe, and you can do a switch on the tag and do a case explosion so you get a convenient pattern match breakdown of the parts and such.
mm,
What I hadn't seen for me was I'll make a union out of a random set of other things, which makes total sense. Tag union. Usually I
mm,
see unions put down as I start a thing that says enum or union or something, and then I list each of the separate things. And Java basically makes some Java class. And when I started looking at what Elm was doing, they're effectively another class. And there's like the union's a superclass, an abstract superclass, and everything else is just a subclass. Is essentially what it happens. Okay, but making them out of unrelated parts, it sounds very actually convenient.
mm. And I mean, the one thing is like with this runtime tag is it's basically what you actually interested in is the guarantee that you always know which variant of your union
Yeah,
or which
yeah,
variant of your enum you have, and um, whether it's implemented with a separate field underneath or you're using niches or other things. That's not even
right.
that like important or interesting. It's basically the like that you have the guarantee that whatever you
Yeah.
do, you can always determine which variant you have
I
in
mean,
hand.
I could imagine an
Mm.
implementation which under the hood steals bits from pointers,
Yeah, exactly. Or like in this case with like two classes, you have like a union of two classes. In my language, you don't have subtyping or inheritance, so the vtable pointer alone is enough to distinguish the
which one?
cases of the
Yeah,
union. And
yeah.
yeah,
I have
and
one other question, and I hear somebody trying to say something too. My question is, when do you get to declare that a pet always has a name? Like in your particular example here, not every pet has lives or years, but every pet
mm,
has a name. Can I have something as a pet and refer to its name? And what are the rules that says like every common field is picked up as available to every member of a pet?
so I haven't implemented any of this yet, but the idea is that after this line union pet of cat and dog, you can open your curly braces and then define an abstract method in there
Ah,
with the fitting method signature. So I'd define an
okay.
abstract function name that returns a string, and the classes are like the variants of the union have to implement the function, for instance,
So it
through
becomes
having
an
a field.
interface, a de facto
Exactly.
interface.
Yeah,
Yeah. Okay.
exactly.
Or can you calculate? So if it behaves as a true union, it will be able to find what is the common parts between dog and parts and determine that
They
should be
don't
a name. Should be a name.
yet suppose everyone has a name, but the concrete implementation has a different layout.
Mm,
Mm,
So you
yeah.
can't do a same offset. You still have to distinguish cats from dogs to pick the offset. The
yeah.
vtable one does the distinguishing by saying there's a name function,
Mm,
and both cat and dog have to have some version of the vtable which has a name field for the interface's purposes. If you have subtyping, you're more complicated because the name placement in the vtable has to be coherent across all the subtypes of cats and subtypes of dogs. But that doesn't mean they're placed similarly such that you could make a union just
W-
any old place. So you'd have to have, like Java does,
Mm.
you have to have a separate lookup table.
Well, if I'm understanding what he's saying correctly, I think it sounds like you would have to like add methods inside the pet union, and then those
mhm.
methods could like
Yeah.
uh
Yeah, he's saying add methods.
dispatch. They could
Yeah.
Right,
dispatch on the underlying
Yeah.
type. So like you
Exactly.
have like get name, and then
Mhm.
that would dispatch on a dog, and it would return dog.name, and if it dispatches on cat, and it would return
right.
cat.name instead.
So the
Exactly.
thing that happens here is that, oh, actually, no, you have
Mm,
all your interfaces listed up front. The Java interface problem is that interfaces come along lazily and there's no alignment of the required fields. Like everyone needs a Git name, but they're not necessarily aligned in the vtables because they came along at different points in time. Here, when you say I have a union, no, that's not true. No, it is true. At the time I say I have a union, you have to go into the cat and the dog declarations separately and say, in your set of allowed unions that you're a member of, one of them has a Git name. There's somewhere a Git name that's in a unified
Mhm.
place. So there's some magical crap that happens
Yeah.
when you
It
build
will
the
have
mm,
to
union.
it will have to trace after the fact, does the union conform to what you declared?
Yeah, yeah.
Every type. Every
Well,
type.
right. Java has to do it after the fact, which turns into a search, a linear scan search.
Yeah.
There
mm,
has been papers way back in the early 2000s when Java was becoming hot about how to add and remove classes lazily and have the interfaces still have a cheap lookup, but they involved horrendously complicated algorithms to do layouts of two-dimensional tables basically to go do the interface
mm,
lookups that they could incrementally tweak and add and remove things and
mm.
still have it work. It was not casual algorithms here.
Exactly. Yeah, the way I imagine is that it's basically methods on union. I have like a dispatch where they dispatch it to the appropriate retable of the instance underneath, and the question whether
You have a
I
union
can,
object itself,
yeah,
because you had to put the tag there. So its
yeah,
memory identity is different from cats and dogs, and now you can
yeah,
attach to its vtable a similar get name that does something. Yeah,
exactly. And
yeah,
the question whether I can maybe line the layout of the retable of cat with the layout of the VA of the vtable of dog is then basically an optimization problem. It's basically if the
yeah,
whatever the just-in-time compiler sees I have a cat and a dog and it's excessively used in only this one specific union, then it
yeah.
might make sense to say, well, let's have a look at the methods defined in that union and figure out whether we can align the method table entries of cat and dog such
This
that
is
we
ahead of
save the
time.
dispatch.
This is ahead of time compilation. You're
Mm,
doing this at ahead of time during compilation when you decide you have the world of what a union, what cats and dogs and the pets will be. Guess you don't have to
mm.
have the whole world, but you have to have cats, dogs, and pets. And
Yeah, I'm basically at link time. I can decide it at the earliest. Like when
yeah, I think
I
so. Right. Yeah, I was trying to think
like
if you could do it even
at
earlier.
dynamic link time, like in terms of just-in-time compilers.
Yeah.
So at class load time in Java,
Yeah.
comparably.
It'd
Yeah,
be nice if you could do it earlier, but I'm thinking you're right. You can't.
Yeah, I actually am not a big fan of having dynamic class hierarchies at dynamic link time. I prefer that. I think it optimizes a lot better if you can say every inheritance hierarchy has to be at static.
Yeah. So just so we're clear here, you're wrong on that one. Having lived the Java experience and knowing everything I know at runtime, I have the perfect actual runtime layout information every time. And if you add classes or remove them, I still have that perfect knowledge and I will generate code for it. And there are many, many times when the C++ guys have to implement subclasses for cases that never actually run in practice. And the Java world, those classes never actually get loaded. And the abstract class ends up with a single implementation out of the 27 that are available in the jar file that never get touched. And he takes the single one and just says, you're not a pet. You're actually only a cat because this crazy cat lady only ever talks about cats. And you get a better class hierarchy every time.
But isn't that the same as doing link time optimization? It's just when you do it.
Yeah, now do it even later. You link time, someone presents to you a person class, and there's child and parent and employee and manager and policeman and fireman. There's 2,700 subclasses of person. Okay, fine. Then you go run the program and you discover that somebody's only ever talking about employees. And so abstract class person happens to have one implementation. And that's actually a really common thing, especially around frameworks. I go to my config file, I ask, am I using the arrow style or the Windows style or some X, whatever style for the Windows. That's never changing for the entire application's lifetime. There are 27 variations on themes. I picked one.
Mhm.
When you say, give me a theme, it's actually, give me the aqua theme with whatever, blah, blah, blah. And that's the only one. And it's all optimized that way. And that's what this is even later than link time. It's at runtime. And it, in fact, in big applications, little applications, everyone fine tunes. In big applications, you get a lot of junk classes that you never load, and therefore you can optimize on.
Going back to Theodore's question regarding a common supertype,
Mhm.
it's like I try to get away without it. Basically saying like if you want to be able to call name, for instance, on your union pet, then the name function needs to be defined on pet. It's not sufficient that all variants satisfy the signature. And the motivation is basically to have a better, more documented control over the interface such a union hierarchy
Mhm.
exposes to the outside world. It's the
Uh,
same for not deriving any special interfaces. For instance,
mhm.
um,
Struct type,
it's it's
structural typing versus nominative typing.
Mhm.
exactly. It's like for instance, if like cat and dog both implement hash or equals or comparable or something, I would also not make my union of pets pretend or act like it implements a hash or equals or
Comparable.
comparable
Yeah, comparable on cats and dogs. Yeah,
without explicitly documenting that
yeah.
on the union type itself.
Mhm.
There are a lot of places
And
where I think structural typing is really good. And then there are also places where I think you're totally right, Simon, that nominative typing
mm,
is the way to go because of that. Like equality is another one. What are the rules on equality on pets? This is where Cameron, where's Cameron? We need him. Pets versus cats and dogs.
mm,
Some people will think cats and dogs are never equal and you should always report false. And some people say, well, they got fur and four legs and a name, so
mm,
they're equal. That's just not a pet. So pets can be equal to pets, but cats won't be equal to dogs, or they would be if they were treated as pets. And now you have the question, when I have this equality check, do I mean
mm.
to compare them as pets, or do I mean to compare them as cats and dogs?
Yeah, uh,
But
He
before,
has better
but
examples than I
because
do. Cameron's got these
I,
examples, but
yeah,
they
I
totally
mean,
make sense in the
I
context.
If
mean,
Fluffy the
it's
cat finds out that he's equal to Fluffy the dog, he's going to be angry.
mm,
Exactly, exactly.
mm,
but
I think
because I think Simon defines that hierarchy upfront, he will be able to calculate the commonalities between cats and dogs, meaning that you can code a name without explicitly saying, because it's a real union. If it behaves as a real union, it will show the commonalities between what you're union on.
So the kind of like in this example or the canonical case in my head is I have two variables.
Mhm.
One's a cat, one's a dog. I do an equals check on them. If cat equal dog, it's always going to fail because they're two different unrelated classes.
Yes.
But if I use them as a pet, I have a pet that happens to be a cat and a pet that happens to be a dog, and I
Mhm.
compare them for equality. Now what are the rules? The
You,
rules are pet equality checking as opposed to
yes.
cat equality with everything else, which fails
mm,
for a dog,
So
right?
the go to it would be you won't be able to compare them unless you tell how to distinguish dogs and
I go
cats
to
or
my
how
local
to.
pet
mm,
shelter
Mm.
and they have their big database example things and they're just mixing up stuff in hash tables and doing checks on them. If they want to know if I have a pet and you have a pet and these pets are equal, they do a pet equality thing. But
Mhm.
if they pull up a person and a pet or whatever out of their database and they ask the question, it wants to fail. But
Mm.
somebody who comes in and says, I need a cat, now they have to do cat equality checking and not pet equality, and you want both at different times.
mm.
Mm. Mm. Mm.
I mean,
Now,
I'm fine with
I mean
providing that
something like this.
functionality And
Let's
it's not even, I
say,
think it's not completely about structural versus nominal typing. It's more about explicit versus implicit typing. Like I'm completely fine for Union to offer all kinds of methods and interfaces, but it has to declare them explicitly. It can't,
mm,
Yeah.
from my perspective, it can't just grow a hash implementation just because cat and dog both implement the hash interfaces and so
All right.
on.
Now, when you decide that you're going to add a hash implementation, does it immediately flow into the cat and dog hash, or do you get to write? It's the equals test. If I declare my union has an equals, now which equals gets used when I pull up a known cat and a pet? Do I do a pet equality check or do I cat equality check where the other half of the equality is a pet? This is a classic example. I have two subclassy things and I say x dot equals y. Is that transitive or reflective, whatever? Is it symmetric? Um,
Yeah, I think I envision basically two possibilities how this can go. So one approach is to say, okay, cat and dog both implement the trait hash. Union of pet, union pet should also implement hash. So I say union pet of cat and dog implements hash or something or whatever the syntax is. And then I have to provide an implementation. So I say, okay, I have a method hash, and that method hash does whatever it wants to compute the hash code. For instance, delegating to the hash of cat and dog underneath. But that's basically the choice of the person implementing it. And the other approach is, of course, saying, yeah, well, I have a derive annotation and put a add derive hash on union pet, and then the compiler or the runtime does something, and there I have less control over it. And of course, it's easy for hash because there the types don't matter. It's like you don't have an input argument except the instance, and it returns a number. The more interesting case is something like equals or comparable because there are type parameters present, and if cat and dog both implement equals or comparable, they implement that equals and that comparable with different type parameters for each. Yeah, like you have like comparable of dog and comparable of cat, and the signature of that compare method will probably take that into account. And that's actually the hard question that I haven't worked on yet, how one could make that work for unions of such types. Like I have a union pet and I want it to be comparable, but the two underlying variants, which are comparable, differ in the type parameters, and that's something I will surely have to look at in the future.
as it stands now, we can only for now check the explore the what is the tag, but be it in a pattern match or an if statement, you can explore is this pet a cat or a dog and treat it as such.
I mean, implemented isn't there is not enough implemented yet to do
Okay.
anything useful.
Yeah.
right.
That's basically number two below
Yeah.
my current approach.
Well, maybe we want to move on here. I know Ryan
For
has
you more,
something he wants to
yeah.
talk about too.
Yeah, so basically I have like this union keyword in my language, and it works and does things, just not the things I just showed you above, because I took the old enum keyword and simply renamed it to union. So it supports the old pre-existing enum style unions, so to say, where you had variants in your union or enum body you referred to, instead of this algol 68 style approach. And I've used this approach in a few other places in the past as well. And from my perspective, this approach of taking your closest existing feature in the language and slowly and incrementally evolve it toward the direction you envision feels a more functioning approach over saying I have this old feature in my language that I don't want to use anymore, and I have this new feature in my language that I want to replace, that I want to use to replace the old one, and I build up the new one in isolation, and then I switch over the old stuff to the new stuff, and then I remove the old stuff.
But aren't you
Yeah,
incrementally rewriting the class libraries?
yeah, exactly. Yeah, so basically the approach I mentioned with old and new stuff being built in isolation. What I learned is that, at least for me, that's not the best or the most productive approach. And the approach of slowly evolving the old stuff into the new stuff works much better for me.
Okay.
And yeah, and I'm applying that exactly to the to the enum to union
Yeah. Right.
migration. So I
Okay. I
support
want to. I
all.
want to. We can go back to this, but I want to wrap it up because several people have said they
Yeah,
have
yeah,
other things
sure.
they want to talk about. So Levo says something as a quick question, and then Ryan's up. So Levo, do
Yeah.
quick.
Sure. Arthur, I think I remember you saying that you guys try to cache compiles like across runs. I was just wondering, was there any situation where it worked? Like, because every time I try to do something like that, I found it faster to just redo the compilation rather than try to cache it.
Well, if the question, if there are situations where it works, yeah, but there are there are caveats with this. Uh, we have at least two implementations of caching, very different ones. They had very different performance characteristics. So the first one, the way it worked, we would basically store the initial LLVM IR and all the queries that happened in the compilation. Then on the cache lookup, we would regenerate, we would run the front end, we would generate the LLVM IR, compare it to the one in the cache, and then check if all the requests to the VM would answer the same question. And then we would return the cache compilation. So we essentially would have to pay the cost of the front end and would save on the optimization and the code gen. The other implementation, the next one, works at a higher level. We don't generate the IR. We just compare all the inputs, including bytecodes, constant pools, etc. So this one is faster for a lookup. But the biggest problem that we found was that the larger your compilation, and typically the size comes from inlining, the higher the chance that you'll have a mismatch somewhere. And it's just like if you, I don't know, a simple model, if the chance of having a mismatch in one inlining candidate is, I don't know, 5%, and then you have 100 of them, and mismatching one of them will mismatch the whole thing, like suddenly your chance of mismatching large compilation like grows the bigger the compilation is. But usually the compile times they don't scale linearly, so you pay more for these larger compilations. And in practice, we can match a lot of the small stuff, but we still have to do large compilations. And
Right.
specific implementation of the cache, how much it costs to do a lookup, will change the constants in this equation. But I think there's this like problem that the larger the compilations, the more difficult it is to match. But the higher is the win that you can get in terms of compilation time.
Oh, what about if the code is like a separate module that is rarely changed? Do you find a lot of success, or how does that play?
Can you just state your question?
Okay, so I might have like my main code in Java, and then I have like a library that I use, and they're compiled together. Is there like a way that you can discover that it's like a library that like rarely changes, and does that also have a problem because something changed in the program, or is that like really high success rates of caching?
Oh, before we get into the program changes, we have much bigger problem with changes in the profiles and class hierarchies and all that runtime stuff that we specialize for.
Maybe this could be a separate like a separate day. It sounds rough. Like I have an idea of where you might go with it, and it sounds like it's going to be like a long explanation.
Is this related out of out of curiosity? Is this related to this cloud native compilation?
So the second caching is in that cloud native compilation, and it is shared between different instances asking the server.
Did see a talk, by the way, I can post.
Somebody had a partial comment and they got cut off.
Yeah, I also had something from Matt, but I couldn't parse it.
Okay, yeah, I kind of thought it was from Matt too. I wasn't sure. All right, and Matt's currently muted, and
Am
I
I
assume
muted?
he'll unmute when he can.
Do I have mic?
You do, Jim.
All right. So caching is easy. You just, hashed up the imports post CPP if you're using a C preprocessor.
No, he's just talking Java,
Oh, okay.
and
Oh,
he's
sorry.
pulled up, right? He's pulled up effectively the class files from the jars, right? And then declared, I've done inlining.
Well, Java does it so well without extra hashing. It already is. It's trap shooting every import prior to,
Yeah,
the
the
actual class.
issue he has is he wants to say, not that I've compiled a method in isolation. I've compiled a method plus a butt ton of imports, inlines. And then in a later run, which has similar characteristics, I pull up my cache and say, Mr. Top level do function plus your wad of imports. If you all matched, I have them precompiled. And one of his points was, the bigger the method and the more inlines you get, the more likely you'll fail on something. And then as soon as you fail on any one of your inlines, it's dead. You have to recompile.
Yeah.
Okay, but the content addressable storage, a hash
Yeah.
of a tree of source code
Yeah.
is still a key for your hash, for your cache
Okay. It's a tree of
draw
byte,
back to.
It's a tree of bytecodes, which is probably what he's actually caching on. Yeah.
Yeah.
The source for the JVM is Java bytecodes, but
Well,
that's source.
Either language gives you the opportunity to say, okay, I'm going to put an IPFS hash on this compilation unit, and everybody in the world with IPFS can, use my hash as a C cache node to compile to pre-JIT whatever I have pre-JITted for them, because the Merkle will line up.
So he comments on the cloud side of things was he has a pre-compiled set of guys with top level guy plus inlines, and successive later runs of JITs go to the cloud cache and say, has this been JITted already? If so, I don't have to re-JIT. I'll just pull one from the cloud. And the add-on comment was, and if the methods get large, your chances of getting a hit go down.
Yeah, so in general, it is doable. And we had two different implementations of caching, and they are kind of content addressable caches. Yeah, it's just there are some things that are like not obvious when you start with this.
Yeah.
And this aspect with large compilations is one of them. That's something that we learned like both times.
Yeah, that one. I mean, as soon as you said it makes sense, but I didn't guess it ahead of time.
Another aspect where it is also relevant if you have auto tuning, like Triton DSL for GPU kernels allows you to auto tune things like the threads, blocks, whatever.
Yeah.
Sizes of matrices, sizes of tiles, and you wouldn't want to rerun this auto tuning every time. So there is a project called Triton Deja Vu that allows you to cache the auto tuner state as well as the JIT cache. And it's actually using fairly large hash methods. It's hashing the function, it's hashing the auto-tuner configuration, it's hashing CUDA version, and on and on and on. But it does allow you to persist that, which can be quite useful because auto-tuning adds a lot of time to the compilation itself.
Right. Yeah. Modular is doing similar kinds of things, and for exactly the same reason. It's just a lot of work to do the build out the expressive, whatever, the expansion of your original code into what it's actually going to look like on a GPU.
Just one follow-up. How long does it take Java to compile 5 million lines or 10 million lines? Because I felt like it's kind of fast.
Okay, so Java C to bytecodes is one compiler. I never tracked the speed of it. It's reasonable and not out of control. It doesn't have the pound include header file CPP does because their headers are pre-cooked, if you will, in the class files. Then there is Java bytecodes to x86, let's say, and I track that one very closely. And back in the day, that was 100,000 bytes of bytecodes would be done in, I guess it was in a second. And I would expect you to be about 1 million bytes of bytecodes in a second these days, roughly, given the ratios. And those are all parallelizable and typically parallelized easily and well. So it's
So
like,
if I had like a 5 million line Java project, I can probably be up and running like within 5 seconds.
yeah, but not the way you think. You only JIT the code you actually execute interesting amount of times. So typically when people launch a large Java application, the JITting is running continuously as they roll over things, but they stop and frequently hit iCache and not iCache, IO problems. They're stalling to load config files. They're stalling to open up database connections. They're stalling to get the web server going. And so there's lots of other things going on that have nothing to do with compilation that are blocking your forward progress. Um, so if you look at the launch of a large Java application, you'll get 2 to 4 cores churning out code, and you'll be running some amount in the interpreter. But frequently, after the first few seconds, you're mostly running some version of JITted code, and you'll keep getting JITs as you go. But your time to where the application looks functional is all tied up with like database loads and I/O, and not really tied up with JITting at all. And you won't JIT all 5 million bytecodes. You'll JIT some fraction of them that are actually used in your hot path.
See, with all that I/O and how fast the compiler is, that's why I was like wondering if the caching would help because it sounds like it's just so fast anyway.
There's totally a space. Now, in Arthur's case, he's using LLVM, which gives him higher peak performance, but a much slower compile time. So the trade-off between I/O and
Oh,
compile
right.
is different for him than it is for C2.
Yep, roughly. Like it's a little bit better, but roughly an order of magnitude slower in terms of compile time than C2. Like
Yes.
Oh,
it's
right,
probably
right, right.
7-8x slower. So yeah, I
Yeah.
think if we had compile times of C2, we wouldn't bother with caching.
Okay. That was a question I had because I thought your gains over C2 were more modest, but I was never quite certain. You had gains, but I was thinking there were 10 to 20% gains.
Wait, when I said order of magnitude, this is compile time. Like we are slower 7 to 8x by compile time, but like performance gains. I don't know. We randomly pulled out another benchmark, and it was like plus 30% across like 1,000 tests.
Okay, that's pretty substantial. It was more so than I was thinking. It's interesting. Yeah.
LLVM gets you 30% faster code.
Well, with a lot of work, like years of like full compiler team tuning LLVM specifically for Java. It's not out of the box.
Wow. Wow.
That wasn't the case when I left C2 20 years ago. And I don't know what Oracle's been doing with C2, but I hadn't heard that it had been doing much with it.
They are actually like they are improving. They are catching up. Like we see how they get few things here and there. Like they do the same thing like we do. We rarely get new cases where they are outperforming us, but they are closing the gaps where we were better.
The,
Look at Java 25, for example.
I haven't pulled that one. Okay. And the
So
other thing I'm
every
guessing is that the nature of Java bytecodes has changed over the years. And when I left, there was a certain flavor of them, and nowadays there's probably a highly, whatever. It's shifted what they look like, and other optimizations are more important that I didn't bother with back in the day. Yeah,
I'm
though.
just like surprised about that because every time I compare LLVM and GCC, I found that GCC's gets a lot better code, and then I find bugs in it. So I'm really surprised that it can get you that far after optimizing for Java.
Well, it's a solid optimizer. Like, yeah, there are a lot of things that we had to do specifically for Java, but LLVM by itself does a lot of heavy lifting, all the classic standard things.
Ah,
Okay. I'm proposing we move on to Ryan's topic, but I called a break in the conversation. Okay, I'm gonna call Ryan. Ryan, you're up. And Ryan is still here? Yes,
Oh,
no.
can you hear me? Sorry. Am
Yeah, there
I
you are.
unmuted?
Yep.
Okay. So my topic here is kind of like, what is the right way to do arithmetic operators? And I've kind of got three sort of options in mind, of like how to do this. So my idea, like in a nutshell, is that there would be different operators for if I want to do an addition that is like checked. So I want to say, okay, if this overflows the width of my integer type, I want this to wrap around, or I want it to trigger an exception, like an overflow exception, or do I just want it to be, undefined behavior? And my idea is that instead of this being, like, generally speaking, a property of the integer type, this would be like you would use, like, if I want it to be undefined behavior when it overflows, then I would do like plus and then exclamation mark.
It, I
But
would I would suggest that right away you just toss out the undefined behavior ones.
Uh,
Never do
that was
undefined
my that was
behavior.
my question too. Why does it have to be undefined behavior or not, for instance, implementation defined behavior or runtime
I
defined
would even
well,
not do
behavior?
we
implementation.
can talk about like why undefined behavior makes some optimizations possible that aren't possible without it. But that would be like a whole topic in and of itself of like, okay, here's some like transformation the compiler can do if arithmetic overflow is undefined. And there's a whole bunch of like,
Versus ones where the arithmetic overflow is well defined as rapid.
yes, so there's certain like optimizations you can make
Okay,
if
wait.
you assume that
There's
overflow does not happen.
one more key thing to throw in here, and those optimizations actually make a difference to anybody. Like
That's also kind of one of the reasons why I'm not proposing undefined behavior being the default. So
no,
like,
not the default. I'm just saying even is you add complications to your language, you add complications to the implementation, including what the hell you have to do to make something happen or not. Like specifying it always wraps, there's certain easy implementation. Specifying it's either this or that, you now have double paths in the optimizer that tries to do something if he sees an undefined, and then immediately I'm doing a transformation that says I have an undefined on this part, but a well-defined on that part, and so I can only do partly. Then the end result is it undefined, and it goes to the undefined rules. Is the end result
okay,
well-defined
well,
as
all right.
wrapping?
So I can actually explain. I could actually go over that real quick. So LLVM has or lots of languages. Well, I'm going to use LLVM's terminology here because it's the easiest way to explain it. LLVM has like the concept of an indeterminate or unspecified value, and they also have the concept of a poison value. And if I take, for example, a indeterminate value or unspecified, and I XOR it, the result is going to still be unspecified. But if I take that and I do AND on it, right? Like some of the bits would be unspecified because we don't know what they were as the input. But if there was a 0 bit and I did an AND operation on an unspecified value, I know that those bits have to be 0 because it doesn't matter what they are, right? So some of the bits would be unspecified and then some of the bits would be zeros. On the other hand, there's this concept of a poison value. And if I do any operations through a poison value, the result is poison. So like I can say poison value and 0, and that's just poison. It's not a usable value, right? And this allows it to do a branch that says, okay, well, you cannot branch on a poison value.
So if
And then
here's a question just to clarify here. If I do an unspecified XOR -1, XOR -1. I just flip the bits back and forth. Do I gain or lose anything? Am I keeping
I
partial
think that
knowledge of
just
partial bits?
I don't know if that would. That's a good question. I think that
Yeah.
would. That's
This
not
this
something I'm gonna.
expands to here I have any obvious set of not even obvious, any set of random transformations that pretty clearly do something. I know what the hell they're doing with the bits. And are you
See,
tracking individual bits as known
yeah.
or
So
bit
if it's
patterns?
unspecified, it would kind of track. Like it wouldn't be able to. It's assuming an unspecified but valid value, right? And the
Yeah.
transformations
Okay.
and subsequent operations still are valid.
Yeah. So
Anyway,
I would fall into the camp of this sounds like a lot of complication for user to use in their head. Almost no one will use it, and they'll
okay.
only gain tiny amounts of integer
That's
ops, which are
I
essentially
don't.
free
Yeah,
on
I don't really
machine.
want to like. I mean, I'm not here to defend
No,
the
I'm saying
Well,
undefined
just
behavior
drop
as a concept.
undefined and you're good.
the
But
thing is,
checked and wrapped are interesting choices in my head.
the,
Undefined is not.
these concepts, they make sense at the compiler IR because they allow you some optimizations. For example, you use this undef value to model, I don't know, uninitialized memory, but they don't make that much sense at the level of the programming language. Or poison value. Poison value is a way to like enable some of the optimizations, yeah. So
Well,
I don't see how, I guess, I don't see how it translates into user land and like user
uh,
facing programming language.
okay. Let's sideline that topic for a little bit after.
I got
Um,
another question related to this.
well,
So
let's sideline this topic because that's not the actual topic that I had in mind. And we can come back to this, I think.
I was
So
just wondering if there's any situation where you want to mix like wrapping and overflows because every time I want to not overflow, it's like with a hash function, and that's like that's like the only time I want the integer to wrap. But otherwise, I always wanted to have some kind of exception or complaints if they overflow. So I never would want to mix the operations. I would just have it in the type.
yeah, so that's kind of like where I'm at is like, what's the default behavior, right?
Yeah.
So should like the one default is we can say, hang on, can I share my screen real quick?
You're hacking on the dock, which everyone can see.
Okay. Yeah, I
Um,
wanted to be able to scroll up and down though.
oh, yeah. Hang on. It's
Uh, my
your no.
my defaults for my language is you get an error if it overflows unless you have a type saying this is expected to
All
overflow.
right, try it now, Ryan.
Okay, let's see here. All right. So it's kind of like, all right. So with option one, right? If we make the default behavior checked, this has a kind of a disadvantage. Like, um,
Oh, I have
overflows.
another question on checked. When you say checked, are those checks like Java's? They're perfectly in order. Or are those checks eventually will hit you? Are
I
you
guess it would be in
denying
order.
all reordering and optimizations around restructuring simple integer math because the wrap checks have to be done in order?
I guess it would just depend on the compiler, but yeah, it would start as in
No,
order before the
I'm asking as a
optimizations.
language spec, checks are in order or checks are eventually.
Checks would be in order. Yeah.
Okay, if they're in order, you just denied all reorganization of arithmetic ops that are very, very commonly done for any array addressing math operation.
Well, if there's any side effects, yes, obviously.
The side
So,
effect is you threw in order.
well, if the other additions don't have side effects, then it could potentially optimize that out. But yeah.
You're asking what does an optimizer do to make life better? I'm saying as a first cut, if you demand the exceptions are done in order, the tests for overflow have to be done in order, or that be done at some point where you can throw them in order. And that puts
Yeah.
a big limit on all kinds of optimizations that follow.
Yeah,
Okay,
you
but that's not.
basically for every reordering you first had to prove that the check that you have generated based on your language specification will actually never trap.
Yeah, you can't trap
Right.
the-
prematurely.
Sure. Well, like what's
Curious.
the right default behavior? Like between so like because the default could be wrapping, the default could be exceptions, or you could do what C and C++ do, which is that it depends on the type of the integer.
Yeah. So I watched Java's use of all integers are promoted on load to 32 bits or 64. And I've fooled around with it a bunch. And I think the real answer is you should promote on load. In memory, size counts. You have to have small size. Once you load it, just go to the maximum fast, easy path, 64 bits. And now you do 64-bit math, wrapping on 64. If you later store and you need to chop it down to size, that happens for free by all hardware on the planet. Right. So effectively you do scroll up your option. Java
Well,
does your option
that's
2.
not the yeah. So that's not really the topic that I had in mind. The topic is not like, okay, what's the semantics of a addition that wraps, or what's the semantics of a check? It's like more like what should like it's basically like which of these default behaviors
Yeah.
is kind
You're
of the
asking
best.
what are the default behaviors, and I'm asking what are the behaviors at all, so I can sort on
Okay.
the defaults.
All
And
right.
one of the behaviors is that you don't you promote immediately, silently.
Okay.
You
So
all
there
do
there are
math
no
at full size. That also
that's an
wraps at each
implementation detail,
smaller. That
right?
wraps at each smaller size as well. So semantically equivalent, hardware runs equivalent to wrap if you've pre-expanded.
Yeah, I'm not really discussing the implementation at the moment. I'm more like, okay, here are the semantics of the language. So these are the three behaviors. Like we have wrapping around, we have checked, it throws an exception or triggers a fault. And then we have it's just straight up undefined behavior. That should be B. If it overflows, right? So these are the three options for behavior that you have. And kind of like option one is like, okay, by default it's checked, but if you want to wrap, you can opt into that behavior. And if you want undefined behavior, you can also opt into that, right? Option two is its default is that it wraps around. And if you want to check it, you can, if you want to do a check, or if you want undefined behavior, you can also do that, right? But by default, it's gonna be like a wraparound behavior.
Yeah.
And then the third option is to keep the C and C++ way of doing it by default, but then giving you these options of saying, okay, I actually want a different behavior.
Yeah.
Like I want to do a signed arithmetic add, but I want them to wrap around, or I want to do an unsigned add, but I want them to have undefined behavior if they overflow. So this is like
Brian, I went option 2 minus, or option 4, which is option 2 with no undefined behavior options. You never get undefined behavior.
well, that's not gonna fly for my language since it's C++ like, but yeah.
I know you totally can. You don't have nothing in C++ demands that you must have undefined behavior.
Well, if
You
the
can
goal
just
of my
add
language
a definition for all the places where the spec says and it's undefined. You just add a definition. In my compiler, this is well defined as being blah.
Yeah, I'm not going to do that because I want the performance that the undefined behavior brings.
Well, I'm pointing out that you'll get essentially no performance out of undefined behavior. Like the count of people on the planet who would make a beneficial use of this beyond nanoseconds that couldn't be measured.
Well, that's also why. So my thoughts here, I'm leaning towards option 1 and 2 here, right? Which is by default you don't get undefined behavior. Undefined behavior becomes an opt-in.
Yeah,
right?
I understand that. And I'm just saying your life got complicated by allowing somebody to opt in. Don't allow them to opt in. What happens to their life? Well, they just write the code that they would otherwise write, which presumably for speed, they went to the wrapping one.
But
And did
the
that.
undefined one can be faster than the wrapping one.
Yeah, but
So
by how much? Who gains? Show me the example where the undefined was usefully used to increase the performance of a program by any measurable amount.
And factoring in the amounts lost by the bugs it causes.
Yeah, exactly. Yeah,
well,
yeah, exactly.
If the
number
idea...
one way to write a fast program is to write a stupid, simple version of it and then do algorithmic smarts to speed it up. I have routinely beat C++ guys, sorry folks, writing code in Java, and then because I got done writing the fucking thing correctly first, I had plenty of time to go optimize, and boom! Oh my God, it's so fast.
All right. Let's. I'll do the undefined behavior versus no undefined behavior discussion afterwards. That's my second topic. Okay.
Yeah,
Okay.
I
Let me.
also
I mean,
I really want to say that I write a lot of code that's really fast, and I never wanted to have undefined behavior optimize something. Like
Right.
I always wanted to do it
uh,
personally myself.
I,
Yeah.
I, I mean, the most useful thing would probably be to have some explicit examples where, given your language and your compiler, the undefined variant is faster than the defined variant. And then I think having a look at the numbers and reasoning about what makes the defined variant slower, then probably then it's possible to have an informed discussion about it.
So like, yeah. So option. Keeping on topic here, and again, I will do this debate on like having undefined behavior versus not, but just afterwards. Okay. Um. So like option one, most of the time, overflow is undefined. Is like not sorry, not undefined. Like most of the time, if you overflow, it's a mistake or like a bug.
Yeah.
And recognizing this, I feel like the safest option is to make the default checked and throw exceptions.
Yeah. Now there is a cost to that,
Yeah, the cost, right?
and
The
you've
cost
missed the
is
cost in your list of costs.
no, it's right here.
No, no.
Basic.
Where is the cost? Might make many expressions less performant due to many branches. And above you, you said modern CPUs can predict, making performance impact minimal.
Right.
But the next piece you're missing here is the set of branches, the volume of branches will also impact your iCache, which will have a direct measurable negative performance impact.
What?
You're
I don't think so.
okay. Go measure
I
it.
think
And go ask every.
so.
I have seen so many languages say we're going to do typed integer math, and the answer comes back immediately. They slow down by 20, 30, 40%, strictly because of typed integer math overflow checks.
Yeah, I
Well,
agree.
it's the branch. It's not the
If you have
iCache.
if you have few very well predicted branches, that's fine. But if you litter your code with very well predicted branches, you will take a hit. Like we see this in Java, and like we see this with GC barriers. We have a lot of predictable branches. Once you remove them, you see noticeable improvement.
Okay, so I can say maybe moderate. Yeah. So I know Zen 2 or the more modern Zen processors switch from doing a single branch prediction to doing two in a row. So you can take a branch and it can predict that branch, and then it can predict a second branch. So it can be double speculative, right? On the more recent Zen CPUs. So it's less of a like the branches are less of an impact than they used to be relative to other things you do because you can now go down two branches during a speculation path instead of just one, right? So you can go, it can predict branch A, and then it can hit another branch, and then it can predict it and keep going. Whereas before that would like trigger a stall because it would only predict one branch at a time.
So the 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 kind of the mental trap I'm hearing is, hey, I'm going to make my defaults depend on the current CPU implementations. And if I go backwards in time,
No,
I
no,
will
no, no, no,
say
no. There's nothing to do with that. The default is
that your
either.
argument you just said was the cost is
Oh,
moderate.
okay. So that like in the design, okay, not
Yeah,
like what the default is at runtime.
right.
It was,
If I
that's
go
not
back
based on the CPU.
over 20 odd years and stare at why people said CPUs can and can't go fast, this problem falls down into related to speed of light and getting the next thing in. And they're always iCache bound or branch prediction bound. Here, if overflow is rare, you're not going to branch predict fail, but you are going to lose on iCache. That is something that has not improved in the last 20, 25 years. So I thinking guessing that this will be a free extra thing to do is
Well, it's
wrong.
not free. Okay, I'm gonna say
I think it's
moderate
going to be
instead of minimal,
more than
Yeah,
what you're thinking.
let's go through the other options.
right? So so
That's
this is like might make many expressions less performant due to many branches. And then
Yeah.
also this would be surprising. Like if I'm taking my C++ code, I have A equals B plus C, and that was wrapped behavior before, and then I copy and paste that, and then I add a little colon to the equal sign, right? Because, and I'm thinking that will work. And then my code throws an exception because the default behavior is now, like with option 1, is now that is a checked operation, right? So that would be surprising to people in C and C++, right? Yeah. So
do you have a type definitions here? Can
no,
you scroll back?
so no, but it's this says depends on the type of integer. So this would be like follows
So
C rules.
So
Yeah.
you do the math on 2 bytes, then they're supposed to wrap at a byte. This
But-
one actually can be done with the thing I was talking about earlier, where you just auto extend to 64 and do the math. And at the time that you ask something that depends on the high order bit of the byte, or the bit pass, the overflow bit, then you do something about it. That's typically when you store the result somewhere, it has to get chopped.
Yeah, that's not like I guess within scope though. That's
No, it is, because it says you get option number 3's first option at the same time you get option number 2's for the same effort, which is 0. Both of those cost 0. Both of those take 0 effort to implement. They give you the identical answer. Or
sorry,
equivalently.
say again. But this is
Okay.
not.
So the only time that option 2 default overflow wraps and option 3 default overflow wraps on type vary is when you look at the overflowed bits by treating the value that you just got as a signed or unsigned byte, and you can tell that it overflowed, wrapped, or didn't. And at that time, you have to do a bit test. Up until then, the actual math didn't make any difference.
I was trying to say that you can specify the behavior with the type. So here in the unsigned 32, it checks for overflow. If it's promote, the result is if
that's option 3. So option 3 is depends on the type.
auto promote it to a long, and you don't have that problem. So you manipulate that with the specifying the result type.
Yeah. So option 3 is like it depends on the type. So if but if you're saying it would extend,
I'm saying write a piece of code that can tell the difference between options 2 default and option 3 default. Write that code. Tell me the difference between something that would go one way versus the other. And then at most I'll say, and you're going to throw in an integer and operation at somewhere in the compiler. And of course, it's another integer option. It's not a branch. And so the cost on it's essentially 0. It'll be some amount of them because you'll have.
So which one am I? I'm comparing option 3.
Write the code that says here's an option 3. Take the identical code, run it under option 2, and then write some if test that can distinguish these.
Okay, so option 3 would be to keep the default C++ behavior. So for example, let's say I have foo, right? And then I have A I32, B I32. Okay, so I have this, right? And then let's say I return I32.
Yeah.
Okay, and then I return A plus B. Okay, so this is my function that behaves differently under option 2 and option 3.
Yeah.
Where the overflow occurs.
Yeah.
With option 3 in C++, this C++ behavior would be undefined behavior. So like if this overflows, it's just undefined.
It's the it wraps version
because
of
it's signed or
yeah. So in option 2, this would wrap. In option 3, it would produce undefined behavior.
I'm sorry, where does it produce undefined behavior?
With this
to clarify, if your loop does like some kind of like compare, it might just skip the compare.
You need an if test in an example that distinguishes between them.
You can't because it's undefined. So undefined behavior.
Okay. All right. So I'll change my comment. Maybe this changes the entire discussion. I'm expecting a option 3 behavior to do the wrapping one. I'm sorry, I'm looking for comparing the wrapping and then truncate on type versus wrapping and not truncate. And that was what I was expecting you to pull out of option 3 there. The B plus C default depends on type of integer I was claiming was always well defined as wrapping.
Oh, okay. So this is like to follow the C and C++ convention. Like the
Okay,
default
then
is it
yeah.
works like C and C++, where if you have signed overflow, the behavior of the program becomes undefined.
I get it, and that's not a thing that I would agree to either. So I'm not looking for that example. And then maybe the argument goes away. It's always in my head that in C and C++, while the spec says this, every implementation of the planet does wrapping. So
No, they don't.
wrapping. No, it's
That's
not 100%, but the
it.
vast
They
majority.
no. They definitely do undefined behavior optimizations by default. Let's pull up like Godbolt.
Oh God! All right, you're saying the ones that says yes. Well,
No,
this is why I don't do undefined behavior there. All right, I'm
my
sorry.
favorite, my
I'll
favorite,
retract. I'll retract. No, you don't have
my
to go.
favorite
This
is
I know happens, so I'll retract. I will say, uh, uh, wrapping on a wrapping that truncates at smaller bytes and a wrapping that does not truncate can't be told apart without some very specific tests that are both rare and cheap to run. That's what I was heading for. So not taking the spec of undefined behavior from C++ when you wrap to overflow.
Okay,
And
so
then this argument kind of goes away. So I'm looking for another option. None of your above options are the ones that I would like to see.
yeah,
I would like to see a
you
two.
want this one without my undefined
Yeah, right.
behavior.
Yeah. And
So
that one too, where you also did wrapping on the subword, subtype, subbyte sizes, whatever, sub 64. Also, I would accept and claim it's essentially identical, and it's very hard to tell them apart.
like if you add two integers together, it creates the result that's of a larger integer type that can
Silently
fit
under the
both.
hood, they were promoted immediately to the largest integer type the processor handles well,
Well,
64.
okay.
And
That's
then you
not
did all your math
really.
at 64 wrapping. And then at the end, when you had a result and you wanted to treat it as if you had done all that math in byte-sized operators instead of at 64-sized operators, you do nothing. The low 8 bits got the byte-sized operator done.
So I
The
don't
fact that
like
you
that
computed
approach
some extra bits didn't matter.
because then the way your code behaves depends on which CPU you compile on, which is a behavior that I've
No,
tended to avoid.
right. So you don't do it that way. You pick a spec that everyone uses for the current largest easy integer, which is 64. Just put it in the language. I auto promote you to 64.
Well,
Do
what
all
if
the
I
math.
declare an I-132 or 128? Like,
Yeah,
what's
you could do 128, but now you're going to cost yourself more expense
what's
than
what's
everything
the
promoted to 128.
well, no, I'm just saying, what if I declare a I-128? Because there's no limit in my language.
No, you could. That's not what I'm
You
saying
just
here. If you do 128, then you do 128, and you burn two registers for each value, and you have to do the carry bit.
no.
Oh,
What I'm
great, and that's
saying is
fine.
that
You asked
in
for
my
it.
language, there's no limit to your integer size.
Yeah, right.
If you
Not
say
saying
like
that. I'm saying values less than 64 under the hood promote.
I don't
And
like
then
that,
because they're promoted, the math is done in 64 bits.
but
Now
that's
you
like
want to say, oh, but
arbitrary.
I actually wrote I8. Like instead of writing I20, 120, write I8. There's a version that says the implementation keeps it as if it's I8, but the code that it'll generate will be all 64-bit math, and it'll be stupidly easy to go deal with if you actually can tell the difference between I8 and I64. So given that you're going to get 64 as the compiler will do an obvious thing, like if you do subword writes to Intel registers by doing bit math, you're going to pay some big cost to actually keep it bit by bit by bit
Well, the
truncated to
compilers,
the math size.
yeah.
I
So
think we're arguing
obviously,
over a point that doesn't make a whole lot of sense to argue over at this point. There is I could write. I'm going to take the control back, so I can write an alternative syntax, and you can go stare at. Uh, no, I'll do it in my own version of the doc, so you can scroll where you want. I'll go find the version of the doc here. There is a thing here that's just not. It's just really easy to deal with, and maybe finish out where you're headed here, and then see if somebody else has something different about what they think the defaults should be.
I just rather it simply be checked by default, and then if the user wants it to be otherwise, he has to explicitly say it.
Going back to the question of which option to choose. I think this is also another case of the approach of minimizing harm to the user. It's like asking the question for every option. I have this option. User might have misunderstood it or has written sloppy code. What's the worst thing that could happen? And I mean, there's like the one variation saying, okay, person wrote code and I expected it to throw or fail on overflow, but it wrapped. And the other way around is I wrote code expecting it to wrap, but it threw an error instead. And I think that's an important point of view to have when picking the right choice for your language.
Yeah, I think like obviously surprise exceptions are could throw people for a loop, you know, like
It's been a cost to test every integer, significant enough performance cost to test every integer forever and a day that has been typically voted out for performance reasons.
Yeah. I mean, what about doing the Rust way of saying wrapping operations need to be explicit and the default is throw on debug builds and overflow silently on production builds?
I would not go there because immediately it means I am using in production a thing that continuously works and my clients all love it, but there's some bug later down the line. I can't get to that later down the line bug because I've wrapped earlier. And so I immediately halt on a wrap and I can't get to the interesting problem my client has. I
But
have to
I
run
mean,
in production builds, change the behavior to wrap, but then I don't have any debug info when I hit the crash point.
well, isn't
sure,
that
but it seems to have worked for them pretty well, I
that's I guess
guess.
the same as like making the plus exclamation the default because like if you say okay, doing this is incorrect, whether you treat that as an optimization opportunity or you say okay, I'm just going to harden the code and do something else. Um, like if it is an incorrect operation, that's kind of like what the concept of plus exclamation would be in this case. It's like, okay, this is you're not allowed to you're not allowed to do this, and if you do it, it's a bug, right? And whether that's okay, I check for this in debug
Yeah,
mode, but I do something
if you
else
have a
at
bug,
optimized level.
no, if you say I have a bug and I wrote a bug and the language says if you write this code, it's a bug, just don't let the language let you write that, and then you don't write the bug. It's not a bug. If you say I have undefined behavior, I launch the missile, I
But
explode, I melt
okay,
your
so if the
computer.
language doesn't let you write the bug, then you introduce all these branches, right?
No, or you
Or
go to it's wrapping, and that's not a bug.
okay, if everything wraps, then now
Right, you're in this weird option world where either I want to say everything wraps, there aren't any bugs around there, it's fast, or I say overflow is definitely an error, and I want to check every single one, and then I have a performance cost. There's another version which says the user says, I don't expect my integer math to wrap. I have 64 bits and I have a count of people on the planet. I'm way, way, way orders of magnitude not going to wrap. So I don't care for checking for wrapping mostly. But here in this funny place, I want to check for wrap because I'm worried about it. Something's going on in my map. So now I'm going to opt in for the wrap check. And then I'm cheaper everywhere, but I have to know where I might fail. And he'll miss all the places where he wrapped and didn't realize it. And that's, you go back and forth. Same as Java and range checks. Every man on the planet screamed about the range checks when they first came out. And then I got them cost way low and they're pretty cheap. And then all kind of bugs just showed up and then got fixed and disappeared because everyone said it's not going to range check, and it did. So everywhere overflow checks are interesting. but the cost of them is still has been too high. Throw in your language and see what people do. I've certainly used languages with endless overflow checks, but I wanted to get something quick and easy done. And the overflow check never blew. But I used the language because it was like Python. It was easy to code some crappy quick thing in it, and that's all you wanted was some crappy quick thing. Okay.
So it sounds like the best option is just going to be wrapping by default for performance, and then if you want to add a check, you can.
That would be my take. I'm also a very dominant speaker on this here platform, and I feel like I'm stomping over people. So I probably should shut up
Okay.
and let you get some
So
other
so
opinions.
all right. Well, here's the second topic that you seem so keen to discuss, which is like, is there merit to keeping undefined behavior as an option for the user? And let's see. Let me pull up some code here. Uh,
If it takes too long, get your example. I'm gonna pull the
uh
share back and
yeah,
just
yeah, you
while
can
you
go
set
ahead
up.
and go to the next
Yeah,
next topic for a moment here.
you got some setup you're doing.
Sorry, hang on.
In fact, somebody, I'll say Levo threw down a Godbolt link
What?
that no, he didn't Microsoft one. I have seen these Godbolt links before. They make sense
Let's see.
as a right.
Yeah.
Here's a
So
let me pull that up. Let me share this. This is
but
from Levo's link.
there's plenty of examples of those though. Let's see here, because
Right,
like I can try and Google for a good one.
right. And this is the test
Uh,
that basically says uh, if you went off the end of the table that was incorrect, you didn't do incorrect, so therefore you didn't go off the end of the table. Therefore, you can say something about I. Um,
mm,
and this guy says something about right. And he gives up on the search.
alrighty.
Oh yeah, undefined Jim, undefined totally dings determinism. There is another version of undefined that says, but it happens in order. It's kind of a version that says I throw an exception at this point in the program, which falls into the camp of I'm checking. But the example that this I have up and I imagine Ryan's working on is one that says basically I can go out of order,
Okay.
therefore I have
But
time travel according to which compiler
I
came
mean,
which,
isn't there like
deterministic.
a recent, I think, C++ standards proposal that restricts how much time travel is allowed nowadays? I thought I read something. Let me have a look.
We have this really strange argument here. Oh, no, it's not. Right. Yeah, he says he runs to the table and he says 0, 1, 2, 3 may have been false, but you keep going then. And then when you hit 4, you're going to return true. Um, so you're always going to return true.
Well,
And in
the
fact,
exact reasoning that doesn't, the exact reasoning is there is undefined behavior in this program. And then the answer can be anything after that.
yes. Okay, fine. Right. I am implementing in my head a reasonable algorithm for optimization which says on 0 through 3, it'll keep looping. If it's true, if it's equal, it's true, and returns true. If it's false, it keeps looping until it hits 4, and then it can be true because you run off the end and I can do whatever the hell I want. So I could, yes, say, oh yeah, it's just true.
So
And
are the
if I whip out my lattice theory of constant propagation, I would claim the undefined load equal v says I can be anything I want, which turns into I can return true. It's fine. So yeah, I can get this one. Oh, here's another. Simon has a different
Yeah,
one.
I found the follow-up blog post to the one you have open, but not the standard proposal or paper I was looking for.
Okay.
Yes. So you can't unwind the missile you already launched. Please, Mr. Missile, go back inside the launch bay. I didn't mean to actually blow up the world.
That's why we're switching to drones.
Well, we could. Please, Mr. Drone, pick up the grenade you just dropped. Don't let it hit the guy, because I meant not to do that. Yeah, sure. This is even going like past the end of the time for the program. This is why I don't believe in undefined behavior, like as a philosophy for making your language. Don't bother with undefined behavior. Just don't do it. All right, Brian, you got an answer yet?
I'm looking for a good piece of code here.
Well, we had
Just
some
have to
examples
keep
already, so I
being
think we
dumb.
could walk away from it.
Sorry. Examples of the optimization for undefined behavior?
Yeah, here's one
Sure.
right here. This
Okay.
loop says for I equals 0 to 4, but the table is only size 4. So when I comes back through as 4, it's off the end. So in the first 4 iterations, if it was ever false, you would just carry on in the loop. And if it was ever true, you return true. But on the 5th iteration, when you're at the end, what value comes out of table sub I? Well, it's undefined. So the compiler is allowed to assume it's equal to V. Therefore, it also returns true. Therefore, you're now done with the loop and you only ever return true. So therefore, the body returns true. And here's the optimized code, return true.
Yeah, that's a bad example though. That's not very practical. Like, because like what we want to see is like an example where it made legitimate code faster. That
You're looking for undefined behavior, let things speed up as opposed to just time travel. So this is a discussion about why it's bad, and you're looking for why it's good. And
yes.
I'm like, don't even bother with the why it's good because the bad is so bad, it's bad. It's just like, range checks on Java were, bad for performance, except they weren't. And then they were so good, they were good. And then no undefined behavior. And wow, look at that. Shit actually debugs correctly or fails what's going to fail without buffer overflow, blah, blah, blah. Never mind. All right. If you don't find one, I'm going to make you bring it next week.
Let me see if I can
I
make
have
one.
seen
I
these
think
as
you
well. Somebody,
I think you need to look in the domain of inserting backdoors in your program because you're a nasty spy.
well, that's the other bad one.
Wait,
I'm
that's
helping,
kind of
trying to
bad.
help Ryan. There is a good example. I have seen one where some funny optimizer tricks did something similar to this, and they said, "Therefore, thou shalt never be null," and I'm going to optimize accordingly. And that was actually the right thing to do for performance. But it was undefined behavior, relied on undefined behavior. I've seen this before. So there is an example. I don't claim I'm going to ever agree that I want undefined behavior in my languages. Somebody somewhere might gain from it, but I claim it's very, very few and very far in between. And as Simon already said, there's so many bugs lurking there. Just walk away. I guess the other thing you can't say, Ryan, is that the undefined behavior gives me more performance on every compiler. It only gives me more performance on a case-by-case basis because it's undefined and different implementations do different things.
Yeah, I'm not sure if there are any compilers that don't do this optimization here, but let's see.
You got it in the docs
Is there
somewhere?
is there like an argument of like maximizing like total utility where you say, well, okay, maybe there is a case where
Yeah.
it's a pretty big win even for undefined behavior, but even still,
Yeah,
are
that's
you is it
my
a good
right.
idea in terms of maximizing, you know, overall happiness or utility
Right.
or
That's
whatever?
my argument. Undefined behavior will cause more problems for your client users than forcing them to define their behavior, deal with the defined behavior. And then because they'll have fewer issues, they'll get their code running faster, quicker, sooner, better. And then they'll be able to spend time on optimization or get to market sooner, whatever. Don't give them that much rope to hang themselves.
Plus, like ultimately, like CPU cycles are cheap compared to most other things that CPUs do, like wait for memory.
The integer ops, the exception checking on ints is still, in my experience, which is getting a little stale, but been for a long time, is that costs. And you go look at other people who do overflowing integer arithmetic and see that they don't run as fast as Java. And the easy answer is in part because they're paying for integer overflow checks.
Okay, I found one that's like reasonably basic and
Throw the link in the doc and I'll jump to it. You got a Godbolt link, right? Put it in the
yeah, hang on a
chat of the
second.
doc and we'll put it in the doc. And it'll last for a day or a week or something.
Let me just fix the code to be a little bit nicer.
Oh, Jim's got a good comment here, which is if you have undefined code, there's a continuum here where at some future update of the compiler, it became illegal. I depended on this for this cool optimization hack, and then I upgraded my GCC to the next dot release, and now that code's just illegal. I like that version. All right, do you have a Brian? Do you have a Godbolt link?
Yeah, I'm trying to make it not use the old C style. Okay, whatever. I'll just turn it back.
I'd say just throw us the link and so we can start staring at it. We're sort of yes, Jim. I had my Mac OS update recently too, and it caused me to go there. Excuse me.
Okay. See.
Oh no, did you update to the most recent Mac OS?
Corporate defined politics gives me a laptop that's been locked down corporately.
Okay.
So they
And
So
only the
this
Apple has all other things that are necessary. And so on a regular basis, the auto update dog says, "You're auto updating. All your windows are dead."
all right. The link is in the doc.
Session. I'm sorry. You put it in the doc where?
At the end of the
At the bottom somewhere. There's not the last link somewhere down here. Godbolt. Oh, it didn't come up as a link.
Press space.
Yep. So these two are very similar code, but this is a very like straightforward example of where you get better performance out of doing this.
I'm sorry. Where's the undefined behavior here?
So you can they're both compiled with the same options, except one is compiled with -frapv, which makes instead of being undefined, signed integer overflow just wraps around with frapv. And you can see there's like 2 extra instructions. There's a branch that's not in the original without that.
I'm looking for.
It's in L6.
I'm sorry?
It's in the L6 case.
And has 2 extra ops. Now, why does it have any ops here? What is he adding 1 and adding 4 for? Like why aren't you here at all? So like
Add 5. It adds 5 to each element in the array, right?
yeah, but why is the add racks comma 4? He's bumping forward racks. He's doing he strength reduced the pointer. He's carrying an index from I and he's carrying a pointer into the array, which he bumps forward by the size of int, which is 4. And now your claim this is worse because he's added 2 instructions, 2 integer ops, which I claim are essentially free on a wide issue x86. That'll do nothing. But separately, why did he generate the different code? Because the first guy, which one has the wrap? The flags aren't shown. Where are the fighting flags?
The one with frapv. It's on the.
Okay, what does that flag mean?
It just means that instead of being undefined, the signed integer overflow wraps around.
Oh, okay.
I'm assuming that it's the case of if it goes from 32 bits to 64, it. But
no, if he
like,
has I being at the edge of the 32-bit universe or whatever size of int is, and he adds one because he's going 1, 2, 3, 4, 5 or up to size, and he rolls over. Suppose int star array is at the edge of your addressing space and size is very close to the limit of 32 bits. You will wrap over. Now, what's the addressing math for wrap over? This is actually an interesting problem for Java.
So here,
Java has
actually,
the
that
same
that
issue.
doesn't seem to be it. So I'll send you another link here.
This case does not like make sense to me because size is ints, so
Yeah.
it should always be less than. I
Okay.
mean, I can't see why it would wrap over.
Look at the second link.
Wait. What?
I put
Suppose
another.
size is max int.
Yeah. Go look at the next doc. I sent another
Yeah,
link.
I know. I'm going to get there in a second. I'm trying to explain to Levo why would it wrap. R is int pointer R is somewhere in a 32-bit address space near the end. Size is max int. I runs from 0 to max int. That math wraps. Runs off the end
It
of
it
32-bit address, goes back
oh
down to
that
0 and keeps going.
but I is allowed to be one less than
Yeah. Suppose
int
size.
max. So
Well,
at most it can be max size. So I'm not seeing undefined there.
No. The math in question happens in the array addressing math.
hang
I
on.
have
Let me. Sorry, I
int
put the
star
wrong link.
array at some number that starts 0x7FFF, something very high address in 32-bit space. Size is max int. I run all the positive integers from 0 to max int. Somewhere size gets big enough that 4 times I, where I gets so large, plus the base of array wraps.
All right. Okay.
What now is the math? What is the correct answer? What do you want to happen here? In this particular model I'm describing, you'll wrap to 0 page, presumably segv. But the semantics are well defined. You'll wrap, you'll go access at a wrapped address. That will happen to be segv. If instead I made my array fill all 32-bit address space, I only have the code somewhere else. I have 4 gigs of this is the array in 4 gigs. Then it wraps. And because I'm doing integer sized math, it wraps. And so I have a 4 gig array and I'm just adding 5 to here from the tail end back to the start and leaving a gap in the middle where I didn't add 5. And that's completely well defined.
Okay, so the way I'm looking at this is if you look at the for loop, if size is less than 0, it would not execute the body. If size is the maximum value,
Yeah.
it will terminate eventually because it's
Yeah.
incrementing by 1.
Right.
So I don't see why the overflow flag affects compilation because to me it seems like it would never overflow no matter what.
Well, now we have to go ask what he decides the semantics are. But like this could be a completely unrelated issue that the compiler's tickled into
Okay,
strength reducing or not.
all right. That's actually a bad example because
Yeah,
in
right.
this
This one is
case,
not showing what you're trying to show, which I'm agreeing with. But I think actually the issue could just simply be the guy on the left decides he's going to do the addressing math in the op every time. He's going to scale by, I assume this is a scale. I don't see the scale by. Look at that. I can't get the scroll bar to come back either.
yeah. So
Line 29.
Where's the scale? Oh, it's up here somewhere. No, that's set up.
So in this one, I think the problem is actually I just tested that and changed that to be a 64-bit
Yeah.
integer
It's
and
fine.
it went away.
I'll agree that
So
this
that's not a
example
good
isn't showing
example.
what you want, and it's not actually terribly exciting in general. So let me kill it, and I'll go grab your link.
Yeah.
Second example.
So I think this is a better example of an optimization that gets introduced by this. So
Here
this,
you're trying to say if I'm above the first guy above a threshold, I'm going to win and say I found you, and then otherwise I return -1. I didn't find you.
I think the examples we are looking at, they are kind of minor. I think a bigger thing, it might help you to, let's say, prove some of the correctness constraints for vectorization. And that's where it's more interesting. But like I can't come up on the spot, but we definitely have cases where having undefined behavior, knowing that you don't need to worry about the wrapping around. Just helps to prove some of the facts.
In the land of C2, there are a lot of effort I put into to getting the correct wrapping math. Exactly the case where your index I was striding forward was very large and itself was going to wrap.
Oh yeah, that's what you're saying. You had to like take care of this case, and you have to
Take care of it.
prove that this doesn't happen because in Java it wraps around. But if you say, I don't, like, I promise it never wraps around, and if it does, do whatever you want, you don't need to prove this. You get this kind of fact for free.
Yeah.
I'll agree, although that's immediately the door opening for the
Oh yeah,
overflow.
oh yeah. All the previous things like stand true. It's
Yeah.
a pretty sharp knife.
So this is like the example. It's like candidate is data I plus one.
Yeah.
If we assume that wrapping is undefined, we don't actually need to like add one. You just check if it's larger than or equal to instead.
Yeah, for
Basically.
whatever reason, he decides he has to do some other check as opposed
So
to.
I honestly I agree with you that this is not a very useful optimization in practice, and that's why I want it to be an opt-in behavior where you say, okay, I want to do I promise that I'm writing some high frequency trading code, and I promise this is not going to overflow, so it's plus exclamation instead of like just being the
Yeah,
default.
okay. So yeah, fine. I'll say Java will certainly do this right. You'll get the hot good loop with a pre-check that happens up front, and the body of the loop will not have any check in it, and you won't.
Well, the data so you have to check each data member in the loop since
You have to check each data member, and he's returning the index of I, which can be computed. The add one can be computed on the exit path. I don't know why he's.
No, it can't because it returns one or negative one. It doesn't return the value.
No.
So the
He has to
candidate,
compare the value.
yeah.
Okay, maybe I'm confused here. He loads the value. He adds one to the candidate. That's what I'm confused by. He compares and says, no, go again. Why did he add one to candidate and say less equal?
Because you see candidate int candidate equals data I plus one.
Oh, there's the plus one. Oh yeah, right. Okay. So he didn't subtract one from threshold.
So what's happening is like basically it's able to take this data plus one and convert that from greater than to like
Less equal? Oh, you're saying that I want to claim C2 would do this. This is a game. Oh, because I have well-defined wrapping.
so yeah, you can't do
C2 would
this unless you
say you
assume.
added plus one to the data, threshold's loop invariant, the add plus one crosses over the greater than to the threshold, becomes threshold minus one, loop invariant, move it out. Yeah, C2 would do this, and that's because C2 has wrapping, integer math.
It would be the FRAP V version. It wouldn't be so the version without FRAP V is a little shorter because it's like if I
No,
say A is
I'm hearing you. I don't know what FRAP's doing, but I'm claiming C2 would do this transform. The
no,
thing that gets you here
that's
can
not
be done with
possible.
well-defined behavior.
No, that's undefined. Because so the reason this optimization is valid is because like data plus one cannot be smaller than data of I. Like data of I plus one cannot be smaller than data of I because if it was, that would be undefined behavior. Therefore, we can convert this plus one and then greater than to like so like if we just check the candidate directly and we say, okay, well, if the candidate is greater than or equal to, or if data I is greater than or equal to the threshold, that is true when candidate in every case except the one case where the wraparound happened.
Where the
And that,
wraparound happens on the data sub I math. This wraps.
yeah, so basically, like you can transform that candidate larger than threshold to be data I larger than or equal to threshold in every case
Yeah.
except for the wrap one. And that's why if you allow wrapping, you can't make that transformation because it's not valid for the wrapping case. But if you say that wrapping case is
Yeah,
undefined,
right.
you can make the transformation because it's undefined behavior if wrapping happens. So therefore, it
Right.
becomes a valid optimization. It's not very useful. Like I would argue that this is such a like I don't want to introduce security vulnerability because I'm sure there are there are legitimate cases where this is like an important optimization that someone's making in a high frequency trading algorithm or something. And
Right.
in those cases, I am okay with making it an opt-in behavior where you're like plus exclamation mark. But
Well, the issue with the other issue that Jim pointed out was that undefined behavior also has the problem that the next generation of the compiler just declares you differently and you lose it anyhow. Because it's not a language spec optimization.
Just don't ever write code that has undefined behavior, and you're golden.
Yeah,
right,
exactly.
that's the idea. Like
Yeah, the
undefined
performance.
behavior is supposed to
All
like
right.
never execute, and
All
the
right.
compiler is just supposed to like it's the programmer's job to make sure undefined behavior doesn't happen, and so the compiler can optimize the code in a way that is only valid if undefined behavior doesn't happen. That's kind of
I
the
think the
idea.
tools should do that.
There's some other language spec needs to decide that this particular thing is interesting or not.
So yeah, the whole
All right.
like notion of undefined behavior is that it's the programmer's job to make sure it never happens, and then the compiler can do transformations that are only valid assuming those undefined behaviors don't happen.
I think that the other piece here is the programmer says, yes, never happens, but also
It
it
happens
does
anyway.
something useful for me. And
That's
we
a
don't have
bad situation.
yeah, we don't have a great example of it does something useful because this is just an integer op savings, which on an x86 is like nothing. It's like chump change.
Well, no,
Disappear.
it's yeah, you're right. So this is not a big deal.
It's not a big deal here. Now, the question is there a big deal somewhere? Maybe there is. All right, all right. I'm gonna grant you this one, although I'm gonna claim the gain isn't enough for me to be bothered with, but maybe somebody else is.
I agree with you in that like I don't want this to be. I think C++ did this wrong by making undefined wrap around the default. So I'm making it an opt-in behavior in my language where you have to like request. I know that this matters. I've benchmarked it and I want undefined behavior for some reason. Like,
all right, I'm gonna claim victory for the alliance, and I'll lose on this one. But I have guests in the house too, so I'm gonna be done like basically on time, a little early. Go get lunch figured out for people. Okay, this is a good conversation. I want to add this piece here. I misunderstood where you were pulling out undefined behavior to be this. I'm sorry, the range check versus the array math. That was where my piece was coming from. Yours was actually this wrapping. And it took me a while to pick up on that one. And as soon as that one wraps, then yes, you have this issue that you can't do this thing. And you did the +1 and the JLE versus the JLE, which is interesting. All right, very nice, thank you. If I can find the stop share button, I'll do that. There we go. Cool. Well, I learned something every day. Yeah, as far as I know, next week. So I was hoping no, it'd be next week. I have to talk to a guy. There's the dude we had on last week has to full-fledged from scratch C++ C compiler that's C11 spec compliant, maybe close to C20 or 23 compliant that he wanted to talk about. And it's from scratch and it's not LLVM and all that. It's a full. So I'm hoping he shows up again because that would be an interesting starting point. Okay. Anything else? All right. Next week.
I do have a topic for next week.
I do?
Probably too long.
Okay.
But I wanted to talk about floating points and total orderings. Whether we should have total orderings on floating
Bring
points.
it for next
Yes,
week. Don't talk now because people
it's
are
in the
thinking
spec.
already.
It's in the spec.
All right. Bye-bye.
Bye.
Bye.